All right, hello everybody, and welcome to your last notes video on metamorphic rocks. Make sure you're listening to the video, filling in the notes as you go, and answering the questions that pop up. Make sure to click submit on Edpuzzle when you are fully done. So, metamorphic rocks. If we break down the word, meta means change, morph means form. So these are rocks that have changed their form. I kind of like to joke about it being a Cinderella rock, how Cinderella changed it to go to the ball and then Midnight changed back. So all metamorphic rocks start as another type of rock. Could be igneous, could be sedimentary, could be another metamorphic rock, and through some process are changed into a new version, a new rock. All of these changes are happening in the solid state. That means atoms that are in the minerals that are making up these rocks get rearranged without melting because everything is happening while this rock is a solid. If it turns into a liquid, we've turned into magma or lava, and that gets formed into igneous rocks. So anything that's happening to a metamorphic rock is happening while it is a solid substance. The word metamorphism means to change. And there are three things that can cause metamorphism to occur: increased heat or higher temperatures, increased pressure, or some form of chemical activity where materials are involved that cause something to change. And really important, again, to go back to that high temperature. If it is hot enough to melt the rock, it will not turn into a metamorphic rock. It will turn into magma or lava, which then becomes igneous. So the temperature is enough to rearrange things, not melt them. There are two types of metamorphism that can occur, and it has to do with the scale, how big an area is being affected. The first is regional metamorphism. This occurs in a much bigger area of rock. Think continents colliding. So with this is how we get some of our mountain belts, because large areas are going under a lot of pressure, and that's causing some change to happen. So a lot of times it happens as a result of plate tectonics. So at convergent plate boundaries where two tectonic plates come together, continents collide. That is a type of convergence. Subduction happens at convergent boundaries where one plate sinks below another, and that can cause friction and pressure and some temperature increases. So this is how we got the Appalachian Mountains in the eastern part of the country, because of two plates coming together, and some regional metamorphism occurred as a result. The second type is much more localized. It is a smaller area of rock that comes into contact. It touches a magma or lava body. And a hot magma body is underground, so we refer to that as an intrusion. A lava body is on the surface of the earth, and that's an extrusion. Intrusion has magma, which forms intrusive igneous rocks. Extrusions are lava, which form extrusive igneous rocks. So in this diagram, label A as your intrusion. This is magma underneath the surface that's cutting into rock layers that are already there, and the heat from the magma is rearranging some materials. And then B is an extrusion, because that's a result of the lava on the surface coming down and cooling. We will talk about what the symbol for contact metamorphism is in class. We'll do more with this diagram. We have two types of metamorphic rocks, or two textures of metamorphic rocks: foliated and non-foliated. Foliated rocks are much more interesting. Here we get to see minerals aligning because of the pressure that's usually involved. So instead of having that random arrangement that igneous rocks have, metamorphic rocks that are foliated, you start to see them lining up. And if you were to look at a foliated rock, it kind of looks like a side view of a book where you could see all the pages stacked one on top of another. You keep adding pressure, that mineral alignment turns into something called banding, which is where we see alternating stripes of light colored minerals and dark colored minerals. So it kind of looks like a zebra striping pattern. And Important to remember, foliated metamorphism only happens during regional metamorphism. Non-foliated metamorphic rocks are less interesting, and it's honestly hard to tell them apart sometimes from an igneous rock and a igneous or sedimentary rock. And non-foliated metamorphic rocks can form due to either contact or regional metamorphism. There are four changes that a rock can go through as more and more metamorphism occurs. The first is something called recrystallization. It's important to note that as you go further into the earth or as you come into contact with the magma body, temperature is going to go up. That causes new minerals to form, and that process of new minerals forming is recrystallization. When you change the temperature, minerals don't like that. They are happy at the temperature that they form at, and that they have formation at, and if that temperature goes up, they're not going to be able to handle it. So they turn into new minerals. As a result of that, your grain size is going to increase, and you end up with a new mineral because the atoms have rearranged. Because you sometimes ends up with new minerals, you can have an increase in the density of the rock because it might move into something that's got more mafic, not more mafic, but more heavier elements in them, or a more increased density as a result of the way the atoms are rearranged. So the more pressure you have with the depth that goes up, you have more rock on top of you pushing down, and that is going to cause the minerals to grow larger and become more dense. The third thing that can happen is giving us that foliated texture where the pressure forces the minerals to get together into parallel layers. And the more minerals grow, the more pressure there is, the more they grow and the more they separate out. And that can lead to banding, which is what this rock in the bottom right corner shows, the alternating light and dark layers. So again, it looks like the stripes of a zebra. And this picture is like a before and after. The picture on the left shows random minerals all over the place. So that would probably be an igneous rock because of that random mineral arrangement. Whereas you add pressure in from both sides, that's going to squeeze those minerals into those layers. So on the right is kind of the far extreme where you have dark light, dark light, dark light. That is banding. And it's going to be hard to see some of these properties in this video, but the left two pictures, the top and the bottom, show foliation, where you have, it looks like layering and it looks like pages in a book, where the rock on the right shows banding. The final thing that can happen, and it requires a lot of pressure for this to happen, is a distorted structure. And what happens is those bands that might be in rocks end up curving and kind of folding onto one another because you've got lots of pressure coming in from different directions. So you end up with this waviness to these. And I think I have an example in class that I can show you. So the difference between banding and rock layers themselves, because rock layers is a sedimentary rock feature, bands don't go all the way through a rock. They kind of look like little strips, but it's not going to go all the way across. Rock layers will. And then with this, kind of the point I want to take home is that metamorphic rocks can form from any other rock type. And I said that at the beginning. I'm re-emphasizing that at the end. We take our two textures of foliated and unfoliated. There are more metamorphic rocks than the 6 we're going to look at, but these are some of the more common ones. We have slate, schist, and gneiss in the foliated category, and marble, quartzite, and anthracite coal in the unfoliated or non-foliated. These rocks all came from a pre-existing rock. Slate came from shale. Schist can come from slate. Gneiss comes from granite. Marble comes from limestone. Quartzite comes from sandstone. And anthracite coal comes from bituminous coal. These are all different rock types. Shale, limestone, sandstone, and bituminous coal are all sedimentary rocks. Slate is a metamorphic rock, and you can put more heat and pressure on a metamorphic rock and turn it into a higher grade one, like schist. And then granite is an igneous rock, and when you squeeze that, those minerals will realign into bands, and that's how you get the igneous rock, the metamorphic rock. Nice. All right, make sure you answer the final question, and we'll talk more about these in class.